Okay, let's get started. We got a lot of work to do. We have to finish up that worksheet today.
Oh wait, I have to put them all on the board.
We're going to do them all, I told you. Anyway,
This is what you do.
starting Monday, quiz every day. Now at the beginning, I'll tell you what the quiz is going to be on. Wait, let me look. Yeah. And then, after a couple weeks, I'm not going to tell you what it is, because it could be on anything. So we're going to start Monday's quiz with a quiz on the cheat sheet. Like, you know those things I drill you on when we go around the room at the end of class? And I have 10 of those. So everybody can start off with a 10 out of 10. Yep. Or a 0 out of 10.
You didn't know.
No, okay.
Chen, just worry about yourself.
It's done.
Okay, where did we leave off yesterday? I remember. Number 13. Okay, they give you a graph. Not they, I give you a graph. So, Jude. Stop monkey me. Okay, so this is -1. 1, 2, 3, 4, 5, 6, 7. This is the graph of y equal f of x. Okay, this is always one of the free response questions, Taruya. Do I have to shout your name like yesterday?
Were we recording?
Anyway, by the way, I can stay to 5:30 today. Yes, we are recording. And then it says g of x is equal to. We actually did several problems like this on the homework, but you guys just don't remember. That's why we have review. Now, as soon as you see this, look at this. You have to be thinking, I think I'm going to use the fundamental theorem of calculus part 1 somewhere in this problem, right? Some of you going, what's that? I can pretty much guarantee that's going to be one of the 10 questions on Monday. Okay, A. Compute g of -1. Now, if this is g of x, how do you compute g of -1? You plug in -1 for x. So you get the integral from 1 to -1 of f of t dt. Now, what does an integral tell you? The area between the graph and the x-axis. If the graph is above, the integral is positive. If the graph is below, the integral is negative. You guys remember that basic stuff, right? Yeah, but Mr. Park, the smaller number's on the top. Well, what did we learn about integrals? If you switch the limits of integration, it negates the value of it. So this is one of your 5 properties of integrals you need to know for the AP exam. They're all listed in the cheat sheet. I'm pretty sure one of those are going to be on Monday's quiz, yeah. You have to show that work. Okay, for this particular problem on the AP exam, it's either right or wrong. It's either 0 or 1. All of these would be like, 1 point each. So there's no partial credit, so it's 0 or 1. So you forget that negative sign and say goodbye, honey. So negative, now, -1 to 1. And this is the graph of f. The integral is going to give you the area between the graph and the x-axis. Hey, that's just a triangle. Now what's the area of a triangle? 1/2 base times height, 2. So -2 is your answer. Just remember, if the area is above, it counts positive. If the area is below, it counts negative. Okay, we keep moving on. B.
I didn't do the problem.
Shh. G of 1. So if I plug in 1 for x there, you get the integral from 1 to 1 of f of t dt. If anybody misses this here, I will be very upset. What is the integral from any number to itself? 0. Then how come some of you are actually only writing it down?
You didn't do the homework.
Yeah, I knew that. Okay, plug in 3. Integral from 1 to 3 of f of t dt. Okay, so here's 1 and here's 3. The integral from 1 to 3 will tell you this area right there, which is a triangle, 1/2 base times height. Survey says 2. D. g of 5. That's the integral from 1 to 5 of f of t dt. Okay, so from 1 to 5. Okay, now this is 2, this is 2. Now what's this area right there? 1/2 base times height. 1/2, 2 times 1. 1. Area cannot be negative. That area is 1. If they ask you what is this area, you say 1. However, the integral is negative. So from 1 to 5, this counts as 2, but that counts as negative 1, so 1. You guys get it? Area cannot be negative, but an integral can be negative. E, g of 7. So if I plug in 7 for x there, you get the integral from 1 to 7 of f of t dt. So what they're basically testing you on is, do you understand what an integral means? So from 1 to 7 would be all of this area. Now again, you got a triangle, 1/2, 2 times 2, so that's 2. So from 1 to 7, this counts positive, this counts negative, that counts positive. So what is that? 2 plus negative 1 plus 2. Rhyme with me. 3. Am I going to be there helping you on the test? No. Okay, next. At what values of x does g have an absolute maximum, minimum, and point of inflection? Okay, I actually need room here, but fit it on the video. I'll just try and squeeze it in. Now, here's g now. This is g. How do you find maximum, minimums for g? For any function, what's the procedure? You take the derivative, and you make a number line. That's what we always do. So this is g right here. How do you compute g prime, the derivative? Yeah, but Mr. Park, it's an integral. Well, how do you take the derivative of an integral from a constant to something? You use the fundamental theorem of calculus part 1. And what does that say? You take that thing and plug it in there, you get f of x. And then the most important part, you gotta multiply it by the derivative of that, which is 1. So here's the connection you have to make. We need to make a number line for g prime, but g prime is equal to f, which is this graph that's drawn right here. That's the connection you need to make with the fundamental theorem of calculus part 1. So basically, you just make a number line for this graph. That's all you're doing. So where does this graph touch the x-axis? Wait, let me look. Negative 1, 3, and 5. What kind of signs do I put? Well, if the graph is above the x-axis, it's plus. If the graph goes below the x-axis, it's minus. This is like looking at your graphing calculator, right, to determine the signs. If the graph is above, it's plus. What do I need to write underneath this to get full credit? G is increasing, G is decreasing, G is increasing. I have my legend, so I can put that for increasing and decreasing. So now we got to answer the question, where does G have the absolute maximum? At what value of x? Well, look at this number line. Where do the maximums occur? At 3 and 7. If you have an endpoint, that's a critical point as well now. You guys even remember what a critical point is? A critical point is when the derivative is either 0 or doesn't exist or an endpoint. Those are critical points. So looking at your number line, maximums will occur at either 3 or 7. How do you determine which one is the absolute maximum? G of 3, G of 7. How do I determine which one is bigger? You computed it already in the previous problem. What is G of 3? It's 2. G of 7 is 3. Which one is bigger? What's bigger, 2 or 3? 3. So the absolute maximum occurs at x equals 7. They want to see that you're comparing all the maximums and then you're picking the biggest one. That's what they want to see. Okay, part C. Where is there an absolute minimum? Well, look at your number line. Where do the minimums occur? Negative 1 and 5. So they want to see you comparing. Here are my minimums. Okay, now we computed these numbers already. This one is negative 2. And G of 5 is right here, is 1. Which one is smaller? That one. So absolute minimum occurs at x equal -1, because -2 is smaller than 1. You guys get it? But look at all the work you have to do to earn the points. And then D, point of inflection. Okay, I'm going to have to go back here. Now, to find point of inflection, what do you need to do? You need to make a number line for the second derivative of g. Well, if this is the graph of the first derivative of g, what would the second derivative of g be? The slope of this graph. Remember, derivative means slope. So if this is g prime, g double prime is the slope of this graph. So the first thing you look for is, where is the slope 0? Look at this graph. Where is the slope 0? No, most graph. No more. There's no place on this graph where the slope is 0. See, if the graph looked like this, then the slope would be 0 there, there, and there. But on this graph, I don't see any place where the slope is 0. So the next thing you look for is, where is the slope undefined? In other words, looking for sharp points. Where are there sharp points? At 1. That's, and what is that? Why does that say 1 there? Because that's the area, fool. At 4. And that's it. So that's what should go on the number line. Okay, now, if the graph is going uphill, what can you say about its slope? It's positive. The graph is going downhill, the slope is negative. The graph is going uphill, the slope is positive. What do I need to write underneath this? G is concave up. G is concave down. G is concave up. And you cannot just say concave up. No, you gotta say what is concave up, because they want you to make the connection between the derivative of the function, or first or second, and what the original function does. So we're looking for points of inflection. So there is going to be a point of inflection at where? X equal 1 and 4, because, let's see if you're trained yet, because G double prime changes sign. Because what is a point of inflection? It's a place where the graph changes concavity. And in order for it to change concavity, the sign of G double prime has to change. Okay, Garrett ball bearings, this is one of the 6 on the fair spots. Or some variation of it. Most of the time, the graph is not going to be straight lines, though. Usually they give you these curves. Sometimes semicircle, like the one I gave you on the test.
If they gave you something like this, couldn't you just avoid doing all of that and just say, looking at the area under the graph?
Yeah, but you want to get full credit. Remember, this is a calculus test. They're testing you on calculus, derivatives and integrals.
But then or if you explain that the integral is the area under the graph, so you just like to multiply it out.
What are you talking about with this? Just do what I do here and nobody gets hurt. I'm going to tell you right now, okay, it's not going to be straight lines. Well, part of it might be straight lines, but you're going to have like semicircles. Or sometimes they'll give you something, but they'll tell you what each area is. What I'm talking about. You got to just be ready for anything. Okay, next, 14. Okay, now, what does this integral tell you? Ooh, the graph, okay, what does the graph of y equal x squared plus 1? It's a parabola shifted 1 up, so it kind of looks like this, from 0 to 6. Okay, so this integral represents this area right there. Okay, now what does it say? Estimate using LRAM3. What the heck is that? This means left
rectangle.
Left endpoint rectangle approximation method. Okay, but on the AP exam, they never use RAM. They always say use a left endpoint Riemann sum. You guys remember what a Riemann sum is?
No.
A Riemann sum is using rectangles to approximate areas. That's what a Riemann sum is.
Wait, we've used triangles?
No, it's either rectangles or trapezoids.
Oh.
But if they want you to use trapezoids, they'll say
I hate
trapezoid.
triangles.
Riemann sum means rectangle. Okay, what does this number here mean? Divided into 3 equal parts. So from 0 to 6 is 6. If I divide it into 3 equal parts, that means each one is going to be 2. Okay, 2 and 4, like that. Walk off, walk off. Okay, now we're going to use the left endpoint to cap off the rectangle, like that. So there's no calculus involved here, people. You just add the areas of those three rectangles and that's the end of the problem. Now in this particular problem, the base of each rectangle is the same, but that's not always the case, right? But it is in this problem, so you can factor out the two. Okay, how do I figure out the height of each rectangle? It's simply the y-coordinate of that point. What's the y-coordinate at this point? If this is y equal x squared plus 1. If I plug in 0, you get? Plug in 2,
5,
plug in 3,
17.
and plug in 6, just for fun.
No need.
Well, you might need it for the right endpoint one too. Let's just put them all in right now. So using the left endpoint, the height is 1 plus 5 plus 17. Woo! And can I leave my answer like that?
Yeah.
Yes! That's full credit.
Do you want us to leave our answer?
Yeah, I do. At this point, I don't want you to compute that. Because some of you have problems. So just leave it like that and nobody will get hurt. Okay, right endpoint. So that means you're going to use the right endpoint to cap off the rectangle like that. So is the base of each rectangle the same? Yes, it's 2, so factor it out. So the height of the first rectangle is simply the y-coordinate of that point. So it's 5. The next, huh? Oh, it says 6? Oh, okay, my mistake. Start all over.
Wait, did you just say it was his mistake?
Silent. Now we're gonna break it up into 6 rectangles. Woo, 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 woo. Okay, the base of each rectangle is 1 now, so factor out a 1. And then the height, oh no, we gotta figure these out. What's that gonna be? 2, 3, 10, plug in 5, you get 26. So it's gonna be using the right endpoint, 2 plus 5 plus 10 plus 17 plus 26 plus 37. Yeah, don't, just leave it. Don't even bother.
Wait, really? That's so weird.
I'll tell you what's weird. MRAM 3. Okay, let's draw a new picture. That picture is soiled already. 1, 2, 3. So, woo! Okay, now what the heck is MRAM 3? Now you're going to use the midpoint to cap off the rectangle like that.
I thought I wanted you to make a trap.
Okay, so the base of each rectangle is 2, so you can factor it out. Now the height of the rectangle is determined from the midpoint. So this is 1, this is 2, 4, and 6. So the midpoint occurs at 1, 3, and 5. We need to, what is the y-coordinate when x is 1? Well, we already did it here, right?
Those
2, which one is this one? 10, and this one is 26. So it's going to be 2 plus 10 plus 26. Are we catching on? And then the next one is trap. What does that mean? Duh, trapezoid. I'm just going to draw a new picture. So, from 0 to 6, how many trapezoids are we making? Well, only 3. It's weak. So, so what you do is you connect the thing with straight lines to make trapezoids. Okay, what's the formula for area of a trapezoid? Which is in your notes. 1/2 the height times the sum of the bases. So, since the height of each trapezoid is the same, you can factor out the 1/2 times the height. Okay, so for the first trapezoid, what is B1 plus B2? We can piggyback on what we did there. What is that, 1 and 5? So that's 1 plus 5. The next trapezoid, what is B1 plus B2? It's going to be 5 plus, what's the next one? 17. And then the next one, what is B1 plus B2? 17 plus 37. And then just leave your answer like that. Is the trapezoid a rule, a Riemann sum? No. A Riemann sum is using rectangles. Is a trapezoid a rectangle? No. Now, EE, using LRAM, that's going back to problem 1. I erased it. Oh, got it. Let's just draw it again and then. I knew I shouldn't have erased it. This is what we did in problem number 1. Okay? Using the left endpoint to cap off the rectangle like that. Is this, what does it say, an over or an underestimate? If I add up the area of those rectangles, is that going to be over the, is that going to be an under, or is it less than or bigger than the actual, oh, did the thing turn off?
I see your home screen for email.
Yeah, it's on your email.
What do you mean, what's on the email?
The email?
That was my email?
I mean, it's on your email. I don't know if it's running.
No, it's still running. Thank goodness. No, that was the camera looks like.
Yeah, it's too weird.
Anyway, is the area of these three rectangles below or above the actual area? It's below, so it's an underestimate. Okay, but on the AP exam, you have to say why. No. You keep doing that. No, not intermediate value. Why is it underestimate? Don't worry, you're gonna get there.
Because it's increasing.
Because
From 0 to 6, half of x is increasing.
Because what is the function name? What is the function name?
X squared plus 1.
Because y equal x squared plus 1 is
Increasing from 0 to 6.
No, you just say increasing good enough.
But it says from 0 to 6.
Duh, I wrote it.
Straight ahead.
Because what determines if it's going to be underneath or above, whether it's increasing or decreasing, right? Okay, but what about the trapezoidal rule? The trapezoidal rule, like in this problem, is it an under and or what did I just say? Under and over estimate. Look at it. Look at the picture.
Over.
It's an overestimate. Why?
Because y prime
No. Lynn? Sorry.
is y double prime.
What's concave? And which concave? Because y equal x squared plus 1 is concave up. Because look, if the graph is concave up and then you connect the 2 points to form a trapezoid like this, then it's more than the actual area. But if it was concave down like that, then when you connect the 2 points, then the area of the trapezoid is below the actual, the area of the trapezoid is below the actual area. So for the trapezoidal rule, it depends on the concavity. But for LRAM and RRAM, it depends on whether the function is increasing or decreasing. You have to say that in your explanation. Okay, and then, oh, darn it. What time is it? Oh, well, we're going to finish, I hope. Okay, here's something we haven't done in a long time. Solving differential equations. This will
a hard one.
be one of the 6. This will be one of the 6 right here. Right down yonder. dy dx equals 2x over y squared. Draw a slope field. You guys remember what that is? From -1 to 1. So basically at these points, and from 0 to 2, like this. At these 9 points, draw a slope field. Okay, what does dy dx mean? Derivative or slope. So here's the point. What is this point? 1, 2? If I plug in 1 for x and 2 for y, what do you get? Are you serious? You can't even plug in the... No. Oh yeah, 1/2. So what you do is you draw a hash mark that has a slope of 1/2 because dy dx means slope. So now on the AP exam, you just have to know the difference between 0, undefined, 1, -1, bigger than 1. Bigger than 1 is steeper than 45 degrees. And then less than 1. And of course the negative ones also. Yeah.
So the first one's always going to be x. I thought that was the y. The y dimensions.
The what?
The -1 to 1.
Duh! X comes before y.
That's true.
Okay, what about this point? What are the coordinates of this point? 1, 1. If I plug in 1 for x and 1 for y, you get 2. So draw a hash mark that has a slope of 2. See how it's steeper than 45 degrees? Okay, this is the point 1, 0. Plug in 1 for x and 0 for y.
Undefined.
Undefined, so it's vertical.
Oh, really?
Wait, let me look. Yeah. I just drew it like 1 minute ago. Okay, what about right here? 0, 2. Plug in 0 for x and 2 for y. 0, so 0 is horizontal, right? This is the point 0, comma 1. Plug in 0 for x and 1 for y. Okay, this is 0, 0. Now what happens when you plug in 0 for x and 0 for y? It's undefined. They'll cancel out and get 1. Undefined is vertical. In fact, come on, now everything over here gotta be vertical, right?
0 equals.
Okay, what about this? This is negative 1, comma 1. Plug in negative 1 for x and 1 for y. You get negative 2, so it's going to be steeper than 45 degrees, right?
Oh, it's
And then this is the point, silence, I'm trying to concentrate, negative 1, comma 2. So you're going to get negative 2 over 2, 4, negative half, so it's going to be like that. That's a slope field. It's just a field of slopes, that's all it is. There's no calculus involved. You just plug in the numbers and draw a hash mark that has the appropriate slope. Okay, next. Solve the differential equation. Okay, how do you solve a differential equation when you have x's and y's in it? What's the technique that we learned that? Separate the variables. Or we call it segregate the variables. So you put all the y's on the left with the dy, and then you put all the x's on the right with the dx, like that. That's called segregating the variables. What's the next step? You integrate both sides. Okay, last one. This is easy. There's no complicated functions here. 1/3 y cubed plus c. Am I going to write the plus c?
No.
No, we're going to mush. Now what about this one? X squared plus c. We take the two c's and mush them into just 1 plus c. Usually we put it on the right, but it really doesn't matter which side you put it on. You guys remember mushing the 2 plus c's together into 1 plus c? Okay, but there is an initial condition. What do we use this initial condition for? To compute the value of c. Now, should I compute it now or wait till later? Yeah, you do it right now, because I remember some of you waiting on a later step. No, do it now. So if I plug in 1 for x, y will be 3. Plug in 3 here then.
27 times a third is 9.
Equal 1 squared plus c. c is 8. 1/3 y cubed equals x squared plus 8. Now I'll tell you right now, this is one of the 6 problems. If you don't put the plus c here, you automatically lose 4 points already. 4 of the 9, gone. Because it changes the problem drastically if you don't put it, that's why. Okay, is that the end of it? What? No, there's still a couple more things to get. How do you finish this problem? You have to solve for y. How do I solve for y? Multiply both sides by 3. And then cube root both sides. And there you go. This is how you solve differential equations, people. This will be one of the 6. Of course, probably they're going to throw you some e's and cosine signs or tangents in there, right? Okay, and then finally, number 17, like this is very current, so hopefully you guys remember all this stuff, right? Areas and volumes. Now, typically, areas and volumes, that's like, this is going to be one of the 6. This is the easiest. Okay? This is the one you got to get 9 out of 9 on. You got to pounce on it, like a wounded wildebeest.
We were the couch on the wildebeest.
Okay, y equal root x. How many times have I used this year? Y equal 2, and the y-axis right here. So this is the region right here. Anyway, just by inspection, what is this? What is this point right here? 4, 2, right? Okay, part A. Compute the area. What integral represents the area of this region here? Remember, draw in the rectangle of infinitesimal width. How do I find the length of that rectangle? Top minus bottom. So what's top minus bottom? 2 minus root x multiplied by the infinitesimal width, which is dx, since I drew the rectangle vertically. And then you add up all of these rectangles from 0 to 4. Since you are doing the integral in terms of x, you go from the x coordinate here to the x coordinate there. And I'm not going to compute these. You guys can compute it, right? That's just x to the half, right? And then maybe we better go one more step. I don't trust you guys. Okay, whose turn is it? Whose turn is it? Where did we leave off yesterday? Simao, antiderivative.
2x minus 2 with x to the power.
Mm-hmm. Do I need to put the plus e?
Yes.
No, because it's gonna cancel out, right? And then from 0 to 4, right? And please plug in the top number first and then the bottom and subtract. And don't assume if you plug in 0, you get 0. Some of you making those mistakes, right? Okay, B. The base of a solid is this thing. Cross sections perpendicular to x-axis are equilateral triangles. Okay, so we have a three-dimensional thing. I put it on a cutting board. I slice it like that. The cross section is going to be an equilateral triangle. The bottom of this triangle is lying right on that rectangle right there. So what's the length of the rectangle again? Top minus bottom. If I know what the side of an equilateral triangle is, how do I find its area? Root 3 over 4 times the side squared. I told you the basic shapes they give you on the AP exam, right? Equilateral triangle, semicircle, square, isosceles right triangle. Sometimes they kind of throw you off. Like they tell you, oh, it's a rectangle. It's a rectangle, but the height of the rectangle is 3 times the width.
You still use this.
What? What? Okay, move on. There's a width to it. There's a thickness to this slice here, which is dx. Add up all of these slices from 0 to 4. This, we just did this like 2 weeks ago, right? Okay, next. Write an integral that we're going to revolve it about the x-axis. Okay, here we go. Now remember, you don't need to know shells for the AP exam. However, you can use it if you want to. Okay, quick. We got 5 minutes. Okay, here's the thing. Revolve it about the x-axis. So if I take this rectangle and revolve it about the x-axis, what is that? It's a washer. Do we have to know washers on the AP exam?
Yeah.
Yes, that's big on the AP exam. So this probability is 100% they're going to ask you that. Okay, what's the formula for our washer? You guys even remember? Pi times big R. Yeah, don't forget that pi now, because that's like 1 point right there for pi. So pi, big R squared minus little r squared dx. Big R goes from the center to the outer edge. How do I find that distance? Top minus bottom. 2 minus 0 is 2. Small radius goes from the middle to the inner edge of the washer. So top minus bottom. Root x minus 0. And then you add up all of these washers from 0 to 4. It's all coming back like a bad dream, right? I hope. And then the last problem, alright, we're going to make it. Take this region, and it says revolve it about the line y equal 2, right here, this line right there. So if I draw in the rectangle and revolve it about the line, what shape is that? It's a disc. And the formula for disc, pi times the radius squared dx, right? The radius of this disc is simply the length of that rectangle, which is top minus bottom. Add up all of these discs from 0 to 4. And you don't even have to know length of curve. Length of curve is not on the AP exam. But you're going to do it when you take the second semester calculus. Okay, we got time for a couple drills.
Drills?
Well, this is, okay, Monday's quiz is I'm gonna give you 10 drill problems. That's what's gonna happen. Okay, who's next? Lynn. What is the solution to this differential equation? Cal. What is the solution to this differential equation? Okay, I'm gonna tell you right now. There's only one that needs to be memorized. This is it right here.
Oh shoot.
All the others, all the other ones you segregate the variables and work it out. But when you see this, you just know.
E to the K.
Y equal Y naught E to the KT.
Oh, that's right. Can I just-
When the rate of growth is proportional to the amount present. You gotta, and you guys gotta look for that phrase too, not just this equation. You gotta recognize the phrase. If the rate at which a population grows is proportional to the population itself, then the equation of the population is this. You know what this is telling me? This is telling me you guys not even looking at that cheat sheet.
I am.
It's just like I gave it to you and you're just coloring on it and stuff. Like the what's that restaurant where you color with the crayons?
CBK.
Macaroni grill.
Whatever.
There's a
That's
bunch.
all you guys doing. No, it's not the menu. The macaroni grill you go on the table for.
No,
right?
CPK.
Oh yeah, CP.
Yeah,
The
CPK.
kids menu.
How come you know that then? How come you know that and not this? Okay, chin.
I know that.
Got 1 more minute. Chin. Dy, dx. No, I changed my mind. The integral of 2 to the x dx.
Oh.
Wrong.
Think you're good, huh?
Wrong.
Plus C.
Plus C. You don't put that plus C, you get a -1. I thought it was times natural log 2. That's the derivative.
The derivative
Okay,
of
Taruya. See, Taruya. Show me you know something.
Oh, I have to split this one.
Oh wait, 1/2 minus,
So that's the answer?
no wait,
No. There's a 1/2.
yeah. 1/2 minus 1/2 cosine 2x.
Okay, so,
Then I do it.
okay.
1/2 x minus sine 2x. No,
Sine 2x, just sine 2x?
no.
I left the space!
Yeah, 1/4.
1/4.
Let's see.
Okay.
He thinks he's good.
Oh, you think you're good? Long. Integral. Tan x dx. Just regurgitate. Negative absolute values plus c. Okay, last one. Hurry! Quick. A to b. F prime of x dx equals. That's the fundamental theorem of calculus part 2. You're gonna have 10 of these on Monday. Hey. Oh, wait! I'm gonna kill you! Nobody goes up. I'll email this. Here. No, that's not it.
I gotta go to class. Last part.
Don't you dare.
Okay, I didn't expect the cake to go through.
Okay, you got multiple choice for homework.
Oh my gosh.
I'll email it to you. Hurry up. Hurry up. This is your homework. Yeah.
What is homework? What is EVO?
See what happens when we do drills? This is how Jaime Escalante does it, though. Okay. Louis. Oh, everybody's here. Very good. Yeah, that's
So what is the verb?
Oh yeah, I told her I can.
Okay, cool.
But then she said it just depends on that person, right?
Right. Hopefully she'll
Well, can't you sing it?
not really. I'll go to do back and forth anyway.
I think you can sing it.
Not the
Oh, you know when we were doing audition?
Yeah.
There was one person, you know the, you know you did, you know you
Yeah.
did, you know you did. I heard somebody on it, they were right on it.
Oh, that's me.
No, I was next to you. There was a girl's voice or something. Who else was singing back up?
No, Fish did the and I did the lower one.
Oh, show us fish. I was like,
Yeah.
oh, that's right on it, man.
Yeah. No, because we were doing vocal harmony this way.
Oh yeah, that was good. Cause I don't know what the heck I was singing.
Because she went like the higher one, and I went you did the lower one. Yeah.
Yeah, it was good. Hey, that's nice. Now I forgot to stop the video.
Oh.
Got the whole conversation on there.
Leave it.